Welcome to today's deep dive, where we are going to master the defenses of data at rest and data in transit by walking through the Hacker Encryption Armory slide deck. We've got an accompanying visual guide, so let's jump right in and arm you with the knowledge you need to ace your certification.
Yeah, I'm ready to go. And I really want to emphasize that this deep dive is designed to equip you with the core concepts required to answer those complex scenario-based questions.
All right, let's start with slide one, titled The Ethical Hackers Encryption Armory, Mastering Disk and Email Defenses for Certification.
Right, the title slide.
Yeah, and looking at the visual for this first slide, we have a heavy-duty server data chassis unit, and it's locked down with a massive padlock.
It's a very striking image.
It really is, and I also want to call out the legend key in the corner. It features a reticle, like a crosshair symbol.
Ah, yes. You definitely want to pay attention to that.
Exactly. So to the listener, whenever that crosshair symbol appears on a slide, it flags a high-value exam target.
Which means it's highly likely to show up directly on your tests.
Right. So looking at this overarching metaphor, the slide calls this an armory. And, people starting in cybersecurity often assume they just need to find, like, the best encryption software, buy a license, and just deploy it everywhere.
Yeah, the master key approach.
Right. So it's not a master key situation, is it? It's more like a golf bag where you need a specific club for a specific shot.
That is the perfect way to look at it, yes.
Mm-hmm.
In cybersecurity, one single tool absolutely does not fix everything.
Okay.
You need an armory of different encryption methods depending on what exactly you are trying to protect. Laptops, emails, backups, they all require different tools.
Because the contexts are so different.
Completely different. When you encrypt a piece of data, you're fundamentally altering its mathematical structure.
Right.
So the way you secure a tiny text file on a local machine is entirely different from how you defend a massive database that thousands of users are hitting at the same time.
And choosing the wrong club, to stick with the golf analogy, leaves a vulnerability.
It leaves a massive vulnerability. Threat actors look for instances where an administrator just, pulled the wrong tool out of the armory.
Moving right along to slide 2, titled The Objective versus the Trade-off.
This is a crucial concept.
Yeah, the visual here is a scale. On one side, we have a heavy book wrapped in chains, and it's labeled Security and Legal Compliance.
And on the other side.
On the other side, there is a microchip labeled High-Speed Processing, and the scale is tipped heavily toward the compliance side.
As it should be in the real world.
Right. So let's unpack the objective first. We are defending laptops, mobile devices, emails, files, system backups. But this isn't just best practice anymore.
No, not at all. It is often a strict legal mandate for organizational compliance.
So we're talking about laws, not just suggestions.
Exactly. Frameworks like the API in healthcare or PCI DSS for credit cards, they mandate encryption.
But then there's the trade-off on the other side of the scale. The slide says complex cryptography inherently slows down system speed.
It does. It always does.
Because the CPU has to do all that math in reverse every time you open a file, right?
Precisely. It consumes CPU cycles, it eats up RAM, and this is key, it consumes power.
Which brings up a great question. Why are mobile devices highlighted so specifically here on the slide?
Well, think about the friction there. Mobile devices, your smartphones, your laptops, they have the absolute highest risk of physical theft.
Because you leave them in coffee shops.
Right. So they need encryption the most. But at the same time, users prioritize fast performance and long battery life on those exact same mobile devices.
So there's this massive tension.
Huge tension. But as the core directive on this slide points out, performance must be sacrificed when data security is legally required.
That is the bottom line. You can't just turn off encryption because the CEO's iPad is running a little slow.
No, you absolutely cannot. Compliance wins.
Okay, let's turn to slide 3, which is broken into two halves. Front 1, data at rest, which says disk, and front 2, data in transit, which says email.
We're splitting the battlefield here.
Exactly. So on the front one half, the data at rest side, the visual is a heavy bank vault door.
Which is very fitting.
So unpack data at rest for us.
Well, data at rest is when we convert hard drive storage into unreadable code. It's parked data.
It's just sitting there.
Right. And it's vital because it protects the physical location of the data.
Like actual backups.
Yeah. Blu-rays, DVDs, external USB drives. And crucially, it defends the volume even when the operating system is powered off.
Because if a laptop is powered off, a thief can just physically take the hard drive out, right?
Exactly. They bypass your Windows password entirely. So the data itself has to be the vault.
Wow, okay. Now on the front 2 side, Data in transit, the visual changes. It's an armored truck driving between two servers.
Because the data is moving.
Right. And this protects sensitive comms from interception. But we have some major crosshair targets here, deep dive targets.
Yes, these are huge for the exam.
The first one is digital signatures. The slide says they provide confidentiality and non-repudiation. Confidentiality I get, but can you clarify non-repudiation?
Sure. Non-repudiation is basically mathematical proof of identity. It means proving a message was sent by a specific person, and they cannot deny it later.
Like, they can't repudiate it.
Exactly. Think of it like sending a registered letter through the post office.
Okay.
The post office checks your ID, guarantees your identity as the sender, and provides a physical receipt of delivery.
So a digital signature does that mathematically.
Yes, using private and public keys.
Awesome. And the second target here is hashing. The slide says it protects message integrity.
Right. Integrity means proving the message wasn't tampered with during transit.
While it was inside the armored truck.
Exactly. Hashing is a mechanism that takes the email, runs it through an algorithm, and creates a unique digital footprint.
So if a hacker changes even one word in the email,
the footprint changes completely. The hatches won't match, and you know it was tampered with.
That is so cool. Okay, next up is slide 4, titled Tool Profile, Windows Encrypting File System, or EFS.
Our first specific tool in the armory.
Right. And the visual here is a small desktop safe holding a single folder, and it has a little digital keypad.
Notice how different that is from the massive bank vault.
Yeah, it's much smaller in scope. So explain the concept of EFS.
Well, EFS is a proprietary function of the Windows operating system. And crucially, and this is what the visual represents, is scope, is individual files.
Okay, files, not the whole drive.
Exactly, not the entire drive, just specific files or folders.
So it's kind of like a hotel room safe.
Oh, that's a brilliant analogy.
Yeah, like it only protects the specific valuables you put inside the little safe, but it doesn't lock down the entire hotel building. The maids can still get into the room.
Yes, that is exactly how EFS works on a shared computer.
Okay, let's look at this section called the creator's lock. The slide says decryption is automatic only when the specific file owner or the creator opens it. Other users are blocked.
Right. Windows ties the encryption key directly to your specific user account.
So I don't have to type in a separate password.
Nope. When you log into Windows, it automatically decrypts your EFS files for you in the background.
But if someone else logs into the same computer,
they get an access denied error. The creator's lock keeps them out.
And that leads to this huge hazard warning on the slide. This is an exam trap.
A very common one.
It says, if a scenario asks how to, quote, prevent a user from reading a file they did not create, unquote, without encrypting the entire drive. EFS is the exact tool for the job.
Memorize that phrase. Prevent a user from reading a file they did not create. If you see that, and it's a shared machine, EFS is the answer. Do not choose a full drive solution.
Because that would be using the wrong club from the bag.
Exactly. You'd be locking down the whole hotel just to protect a passport.
Moving to slide 5, titled Tool Profile, BitLocker.
Now we're bringing out the heavy machinery.
Yeah. The visual difference from EFS is striking. This is a massive vault door embedded into a solid concrete wall, and it's wired to a microchip labeled TPM.
Right, so we're contrasting BitLocker with EFS here.
Because while EFS is a small safe for files, BitLocker locks down the entire contents of the hard drive.
The absolute entirety of it. The OS, the empty space, everything.
The slide specifically mentions swap files and hibernation files. Why is that important?
Well, when your computer runs out of RAM, it writes data temporarily to the hard drive in a swap file.
In plain text.
In plain text. So if you're only using EFS, fragments of your secret document might leak into that unencrypted swap file.
Oh, wow.
Yeah, and the same goes for when you close your laptop lid. It dumps the whole memory into a hibernation file.
So an attacker could just read that file.
If you don't have full drive encryption, yes. That's why BitLocker is so critical.
The slide also mentions additional features for BitLocker, like multi-factor authentication and archiving recovery keys.
Right. You can archive the keys to a USB, a file, print them out, or save them in Active Directory.
Okay, but let's talk about that wire connecting the vault to the TPM chip. The slide calls the TPM the hardware anchor. What is a TPM?
TPM stands for Trusted Platform Module. It's a physical chip on the motherboard.
And what does it actually do?
It validates the system boot component integrity.
Okay, let's translate that.
Basically, before Windows even loads, the TPM checks to make sure nobody has messed with the hardware or the core boot files.
Like a pre-flight checklist.
Exactly. And if the checklist passes, the TPM hands over the decryption key to unlock the BitLocker vault.
And why does that offer maximum protection?
Because the key isn't stored on the hard drive, it's locked in that physical chip.
Which brings us to the welded vault trap. This is highlighted on the slide. It says, if a hard drive is ripped out and moved to another system, BitLocker prevents all access.
Right.
Wait, let me push back on that. So if a thief steals my laptop, takes the hard drive out, and plugs it into their own rig, they still get nothing.
They get absolute nothing.
But they have the hard drive.
They have the drive, but they don't have the TPM chip.
Oh, because the chip is on the original motherboard.
Exactly. The original TPM chip holds the key. The thief's computer doesn't have that key. And furthermore, moving the drive changes the hardware environment, so the TPM validation would fail anyway.
So moving the drive doesn't bypass the encryption, it actively triggers the defense?
Yes. The vault stays welded shut.
That is brilliant. Okay, now we're on slide 6, titled Tool Profile, Vericrypt.
Another fantastic tool.
And the visual here is highly specific. It's a mechanical drafting pen drawing a secure cipher grid onto paper.
Yeah, drawing it as it moves.
Right. So help us understand Vericrypt.
Well, Vericrypt establishes and maintains encrypted volumes, but the key is that it requires zero user intervention during normal use.
Okay, let's zero in on the big target on this slide, on-the-fly encryption.
That is the magic phrase for Vericrypt on exams.
So give us a practical, detailed example of how Vericrypt secures data volumes on the fly.
Okay, imagine you have a secure Vericrypt volume, like a virtual drive.
Mm-hmm.
You enter your password to open it.
Okay, it's open.
Now, when you save a file into that drive, data is automatically encrypted immediately before it is saved to the physical disk.
Immediately before.
Right. And when you open a file, it is decrypted immediately after it is loaded into memory.
So the plain text never actually touches the hard drive.
Never. The software acts like an invisible toll booth, doing all the math in the background right as the data crosses the threshold.
Like the drafting pen drawing the grid exactly where you need it.
Precisely.
So let me ask you to contrast this. Contrast Vericrypt's on-the-fly volume approach with BitLocker's full drive boot protection. How do their practical use cases differ for an actual user?
Well, BitLocker is rigid. It locks the whole machine down, which is great for a corporate laptop. But Vericrypt is portable.
Portable how?
You can create a secure Vericrypt file, drop it on a USB thumb drive, and take it to any computer. Windows, Mac, Linux.
Oh, because it's just a self-contained volume.
Right. It doesn't care about the TPM or the boot sequence. It's a completely different use case.
Let's look at slide 7, titled Symantec Drive Encryption and Disk Defender Diagnostic Matrix.
Okay, Symantec.
Yeah, briefly covering the Symantec visual, it's a hard drive sitting under a transparent shield.
Which represents its nature. Symantec provides complete, transparent drive encryption for all data.
Covering swap files, hidden files, removable media.
Yeah, it's heavy-duty enterprise stuff, but it runs quietly in the background. Transparently.
Okay, now let's look at the diagnostic matrix on the bottom half. I'm going to run through this comparison table, and I want you to summarize the mechanism and the exam keyword triggers for each tool.
Sounds good. Let's do it.
First up, EFS.
EFS is tied to user permissions. The big trigger phrase is did not create, as in preventing a user from reading a file they did not create.
Next, BitLocker.
Tied to system boot and the TPM. The trigger scenario is a hard drive being moved to another system.
Because it stays locked. Okay, third, Vericrypt.
Zero user intervention once mounted. The ultimate trigger phrase is on the fly.
And finally, Symantec.
Completely transparent, overarching encryption. Look for the triggers, transparent, or scenarios specifically targeting swap and hidden files.
So if a listener gets a complex word problem on the test,
They should use this matrix as a mental filter. Ignore the fluff in the paragraph and look for those specific keywords to choose the right tool.
shifting gears from disks to emails, we are now on slide 8, evolutionary flowchart, SSL to TLS.
We are leaving data at rest behind.
Yeah, we're back in the armored truck. So this slide contrasts the old guard versus the modern standard.
Yeah.
And the flowchart visual is really evocative. We've got an old, riveted, rusty pipe labeled SSL morphing into a sleek, modern, high-tech conduit labeled TLS.
That perfectly describes the history.
Unpack SSL for us, secure sockets layer.
Well, SSL is an application layer protocol. It uses RSA asymmetric encryption, but as the slide says, it is the old guard.
It's the rusty pipe.
It is full of holes. In fact, it has been officially deprecated by the IETS, the Internet Engineering Task Force,
Deprecated meaning?
meaning it is fundamentally broken and you should never use it.
Okay, so that brings us to the sleek conduit, TLS transport layer security.
Yes, TLS is the definitive replacement
And why is it preferred for secure email transmission?
because it fixes all the vulnerabilities. It authenticates both the client and the server. It allows them to negotiate the strongest encryption algorithms.
Okay.
And critically, it securely exchanges symmetric keys prior to the actual data exchange.
Using that RSA algorithm.
Right, it uses heavy RSA math like 1024 or 2038-bit just to agree on a secret key. And then it uses the record protocol, like DES, to actually encrypt the data quickly.
So I really want to emphasize this exam trigger on the slide. If a scenario asks which protocol has the most improvements, or is the definitive replacement for SSL, the answer is always TLS.
Always. Even if people still say SSL certificate in the real world on the exam, the answer is TLS.
Moving to slide 9, titled The Builder's Dilemma, Protocol versus Toolkit.
This confuses so many people.
Let's define the terms. The visual is a toolbox full of wrenches, and sitting next to it are architectural blueprints.
Right, and that addresses the core dilemma. People constantly confuse the blueprint with the tools.
The slide says TLS is the protocol, which is the blueprint, and OpenSSL is the toolkit.
Exactly.
So why is OpenSSL categorized as a toolkit?
Because TLS is just a document. It's a set of rules. It doesn't actually encrypt anything.
It just tells you how it should be done.
Right. OpenSSL is an open source library written in the C programming language.
Right.
It actually implements the SSL and TLS protocols.
It executes the required cryptographic standards.
Yes. It is the physical code, the wrenches that developers use to actually build the secure pipe.
That makes so much sense. The slide also briefly mentions Keetsar.
Yeah, Keeksar is another open source toolkit.
How is it different?
It's designed to make implementing symmetric and asymmetric encryption easier and safer for developers. It abstracts away some of the complex math so developers don't make mistakes.
Almost at the end. We're on slide 10, the exam labyrinth, spotting distractors.
Time to navigate the traps.
Yeah, we have a threat radar visual here. And threat 1 is the dyslexia trap.
I love this one.
It lists TSL. I mean, I have to laugh. TSL.
It seems funny now, but test writers use fake acronyms like TSL intentionally to trick speed readers.
Because your brain just autocorrects it when you're tired.
Exactly. You're 4 hours into an exam, you see TSL, you think TLS, and you get the question wrong.
Wow. Okay, threat 2. The network decoys. It lists VPN and IPsec. Why are they distractors here?
Because of the context of the question. If an exam question asks about protecting a hard drive, or files locally, meaning data at rest,
Right.
you must immediately ignore VPN and IPsec.
Because they only protect data actively traveling over a network.
Precisely. They are exclusively for data in transit, so if the laptop is stolen out of a car, a VPN doesn't do anything.
Finally, we arrive at slide 11, the final boss cheat sheet.
The rapid-fire recap.
Let's do a quick volley. I'll read the exact wording from the slide prompt, and you match it to the target tool. Ready?
Get me.
Prompt says, on-the-fly encryption.
Vericrypt.
Prompt says, entire drive, prevent access if moved to another system.
BitLocker.
Prevent reading a file they did not create, not an entire drive.
EFS.
Most improvements, replacement for SSL,
ELS.
open source cryptography toolkit.
OpenSSL.
Excellent. So what is your final study advice for the listener?
My advice is to memorize these specific trigger pairings.
Yeah.
Because when you are reading a massively convoluted paragraph on the test, filled with useless details, you want the real answer to jump off the page instantly.
Look for the signal in the noise.
Exactly. But also, understand why these answers are correct. The difference between a small file safe and a welded vault, or a paper blueprint and a metal toolkit.
That understanding is what enables true mastery, not just rote memorization.
Exactly.
Well, we've talked heavily today about locking data down with these specific tools, but I want to leave the listener with a final provocative challenge. Think about the evolution of computing power.
It's moving fast.
It is. As we move closer to the era of quantum computing, how long will tools like RSA or the current TLS standards be able to hold their ground?
That is the big question.
Right. How long before the entire armory we just built needs a complete reinvention to handle quantum attacks? Ponder that as you review these slides. Good luck with your deep dives, and we'll see you next time.